Before there were oceans, before there were mountains, before there was even land to stand upon, the Earth was already a world shaped by catastrophe. Tonight we begin the complete history of the Earth's greatest catastrophes, not with fear, but with distance, with calm, and with time. Because the earliest disasters in Earth's story are so far removed from us that they no longer feel threatening. Instead, they feel vast, slow, and strangely peaceful. To understand Earth, we must travel back more than 4.5 billion years to a time when the planet did not yet exist, and when destruction was the natural state of the universe. The sun was young then, newly formed from a collapsing cloud of gas and dust. Around it stretched a wide, spinning disk of debris, fragments left over from stellar birth. Within this disk, tiny grains collided endlessly. Some collisions shattered particles apart. Others caused them to cling together. Over immense spans of time, these fragments grew, first into pebbles, then into boulders, and eventually into massive bodies large enough for gravity to take hold. This process was neither gentle nor orderly. It was chaotic. Countless worlds were born and destroyed before they could ever stabilize. The early solar system was a crowded, violent place, filled with unfinished planets colliding in silence. Earth was one of these worlds. At first it was not blue, it was not green, it was not alive, it was molten. A glowing sphere of liquid rock, heated from within by radioactive decay and from without by constant bombardment. Asteroids struck the surface again and again, each impact releasing more energy than the largest weapons ever created by humanity. The ground did not crack, it flowed. Oceans of magma covered the planet, erasing any trace of what had come before. In this era, catastrophe was not an event, it was the environment. Among all these early disasters, one stands apart, a catastrophe so immense that it permanently altered Earth's future. A young planet, roughly the size of Mars, drifted into Earth's orbit. Today, scientists call this lost world Theia. Its path intersected with Earth's, and when the two collided, the impact was beyond imagination. Entire layers of Earth's surface were vaporized. Material from both worlds was blasted into space, forming a vast ring of debris around the planet. Over time, that debris cooled and gathered. Slowly, silently, it became the Moon. This single catastrophe changed everything. The Moon stabilized Earth's rotation, preventing wild shifts in climate. It created tides, which would one day shape coastlines and influence early life. It became a silent companion, a reminder that destruction and creation are often the same event. Without this impact, Earth might have remained unstable or lifeless. Catastrophe did not end the planet's story. It made it possible. For hundreds of millions of years after this collision, Earth remained hostile. Volcanoes erupted continuously, releasing thick clouds of gas into the sky. The atmosphere was heavy with carbon dioxide, methane, and sulfur. There was no oxygen to breathe, no protection from radiation, no quiet. The surface cracked and reformed endlessly as molten rock cooled and shattered. And yet, beneath this chaos, something subtle was happening. The planet was cooling. Gradually, the rain of asteroids slowed. The crust thickened. The surface began to hold its shape, if only briefly. Water vapor in the atmosphere condensed. Rain began to fall, not for hours, not for days, but for thousands of years. Slow, relentless rain filled the low places of the world. Oceans were born not from peace, but from prolonged catastrophe, from volcanic steam and global storms that reshaped the surface again and again. Where magma once ruled, water now spread. And for the first time, Earth began to resemble a place that could change. These early catastrophes were not dramatic in the way we imagine disasters today. There were no witnesses, no memory, no fear, only processes unfolding over millions of years. But they were no less powerful. Without the constant impacts, Earth would not have melted enough to differentiate into layers. Without volcanic chaos, there would be no atmosphere to evolve. Without the moon-forming collision, Earth's rotation might have doomed it to instability. The planet learned resilience early. Each time catastrophe erased the surface, Earth rebuilt it. Each time conditions seemed impossible, new balance emerged. This pattern, destruction followed by renewal, is the central rhythm of Earth's history, and it will repeat again and again. At this point in our story, there was still no life. But the stage was being prepared. The oceans cooled. The crust stabilized. Energy flowed freely from the planet's interior and from the sun above. Earth had survived its most violent youth. The greatest catastrophes were not over, but they were changing. They would become slower, colder, more subtle, and they would begin to leave marks that life itself could feel. If you're enjoying this calm journey through Earth's deep past, you're welcome to subscribe to the channel so you don't miss the rest of this complete history. You can also leave a comment sharing where you're listening from and what time it is for you right now. Many people around the world listen to these stories late at night in quiet moments like this one, and it's always interesting to see how far this narration travels. Now, let's continue. As the early Earth settled, a new kind of catastrophe began to dominate. From space, remnants of the solar system still drifted inward. Asteroids, comets, fragments of forgotten worlds. This next era would test Earth's stability in a different way, not through constant chaos, but through sudden, devastating impacts. Some would alter the atmosphere, some would reshape continents, and some would come close to ending Earth's potential before it ever fully began. In the next chapter of this story, we will explore the age of cosmic bombardment and how Earth survived when destruction fell from the sky. For now, rest with the knowledge that even in its most violent beginnings, the Earth endured. And that endurance would shape everything that followed: fire, ice, and the long cooling of the Earth. After its violent birth, the Earth did not suddenly become calm. Catastrophe did not disappear when the oceans formed or when the crust first began to harden. Instead, it transformed. The chaos of constant planetary collisions slowly gave way to a quieter, deeper struggle, a long battle between fire rising from within the Earth and cold pressing down from space. This chapter is the story of that balance, a story not of sudden destruction, but of slow, planet-wide catastrophes that unfolded over hundreds of millions of years, reshaping the Earth again and again while quietly preparing it for life. As the young Earth cooled, heat still surged relentlessly from its interior. The planet's core remained molten, churning with energy left over from formation and radioactive decay. This heat escaped through countless volcanoes, which dotted the surface like open wounds. Eruptions were not isolated events. They were constant. Lava flowed freely across vast regions, hardening into new land before cracking and melting once more. The air filled with volcanic gases, thickening the atmosphere and trapping heat close to the surface. For a long time, Earth existed in this uneasy state, neither fully molten nor truly stable. It was a world suspended between extremes. But slowly, almost imperceptibly, the balance began to shift. Asteroid impacts became less frequent. The crust thickened. Oceans deepened and cooled. And then, without warning and without intent, the Earth entered one of the most dramatic phases of its history. The planet began to freeze. These events are known today as snowball Earth periods, times when ice spread across nearly the entire surface of the planet. Not once, but multiple times. Glaciers advanced from the poles toward the equator, reflecting sunlight back into space and accelerating the cold. Oceans froze over, sealing the planet beneath layers of ice that may have been kilometers thick. From space, Earth would have appeared pale and silent, a frozen world drifting beneath the sun. This was not a single disaster, but a prolonged planetary crisis. Life, if it existed at all, was forced into refuge beneath the ice or near volcanic heat sources deep below the surface. And yet, Even this catastrophe followed Earth's familiar pattern. It did not last forever. Volcanoes continued to erupt beneath the ice, releasing carbon dioxide into the atmosphere. With no rain to wash it away, the gas slowly accumulated. Over millions of years, the trapped heat grew stronger. Eventually, the ice began to melt. What followed was another global transformation, a rapid warming, rising seas, and floods on a scale almost impossible to imagine. Ice ages ended not with quiet thawing, but with dramatic reversal. Once again, catastrophe reshaped the planet, this time clearing the way for more complex forms of life to emerge. As Earth cycled between fire and ice, another force quietly sculpted the surface: the movement of tectonic plates. Vast slabs of crust drifted slowly across the planet, colliding, separating, and grinding past one another. Mountains rose where plates crashed together. Oceans opened where the crust split apart. These movements were slow, but their consequences were immense. Entire landscapes were erased. New continents were formed. Earth was no longer a static world. It was alive with motion. From time to time, this motion produced sudden devastation. Massive earthquakes shook the ancient crust. Volcanic provinces erupted for thousands of years without pause, releasing enough lava to cover continents. These events altered the atmosphere, poisoned oceans, and pushed life, still simple and fragile, to the brink. Yet each time, recovery followed. The climate stabilized, chemistry shifted, new ecological balance emerged. Earth did not seek equilibrium. It found it through repetition. By the end of this long era, the planet had changed profoundly. The atmosphere evolved. The oceans became chemically complex. The surface cooled enough to remain solid for long stretches of time. Earth had survived fire. It had survived ice. And through these vast catastrophes, it had become a place where life could not only exist, but persist. The greatest disasters were no longer constant. They were episodic, and their consequences would soon become visible in the history of life itself. In the next chapter, we will explore catastrophes that did not reshape the planet slowly, but struck suddenly, from the depths of the Earth and from the sky above. Supervolcanoes, global darkness, moments when the world nearly began again. For now, let the rhythm of Earth's long cooling settle in your mind. Fire giving way to ice giving way to life, and catastrophe quietly guiding the way. When the sky darkened and the Earth trembled. For much of its history, the Earth appeared calm on the surface. Oceans rose and fell with quiet regularity. Continents drifted so slowly they seemed motionless. Life expanded, adapted, and settled into familiar patterns. But beneath this appearance of stability, enormous forces were always gathering. Pressure built deep below the crust, where molten rock pooled in vast chambers, slowly absorbing heat over thousands and sometimes millions of years. Far above the atmosphere, remnants of the solar system continued their silent journeys through space, following paths set long before Earth had fully formed. This chapter is about the moments when those hidden forces were suddenly released, when the Earth reminded everything living upon it that calm was never permanent. Deep within the planet, magma does not rise quickly. It accumulates gradually, fed by heat from the mantle and guided by fractures in the crust. Over long periods, these chambers expand, pushing upward while the rock above resists. Most of the time, this pressure escapes gently through steady volcanic activity. But on rare occasions, the pressure becomes too great. When that happens, the Earth does not merely erupt, it explodes. These events are known as supervolcanic eruptions, and they represent some of the most powerful natural catastrophes the planet has ever experienced. Unlike ordinary volcanoes, supervolcanoes do not build tall mountains. Instead, they collapse inward, emptying entire magma chambers in a single catastrophic release. The explosion tears open the ground itself. Ash, gas, and rock are hurled into the upper atmosphere, spreading across entire continents within days. Sunlight dims, temperatures fall, seasons lose their meaning. One of the most significant of these eruptions occurred approximately 74,000 years ago at a place now known as Lake Toba. When Toba erupted, the explosion was heard across much of the planet. Ash fell thousands of kilometers away. The sky turned gray, then dark. For years afterward, the Earth entered a period of global cooling, a volcanic winter. As fine particles reflected sunlight back into space, plants struggled, animals vanished. Early human populations may have been reduced to small, scattered groups, fighting simply to survive. And yet, even this catastrophe did not erase life. It altered it. Supervolcanic eruptions did not occur only once. Across deep time, enormous volcanic regions erupted repeatedly, releasing lava not in single explosions, but in relentless waves lasting thousands of years. These are known as large, igneous provinces. Entire landscapes were buried beneath layers of basalt. Rivers were rerouted. Oceans absorbed toxic gases, becoming warmer and more acidic. These prolonged eruptions did not always announce themselves dramatically. Instead, they quietly destabilized ecosystems, pushing species toward extinction without a single defining moment. Catastrophe in these cases was not sudden. It was suffocating. While the Earth struggled with forces rising from within, danger also arrived from above. Asteroids and comets, remnants of planetary formation, continued to cross Earth's orbit. Most were small, some burned brightly and vanished, but a few were large enough to change the course of history. The most famous of these impacts occurred 66 million years ago. A massive asteroid traveling at unimaginable speed struck the Earth near the present-day Yucatan Peninsula. The impact was instantaneous. Rock was vaporized. The ground shook across the planet. A shockwave raced through the atmosphere faster than sound. Within hours, fires ignited across continents as superheated debris rained down from the sky. But the true catastrophe unfolded slowly. Dust, ash, and sulfur were blasted into the upper atmosphere, forming a thick veil that blocked sunlight. For months, the world grew darker. For years, it grew colder. Photosynthesis slowed, then stopped. Plants died. Herbivores followed. Predators soon after. The age of the dinosaurs ended not with a roar, but with silence. After the impact, Earth entered a period of deep stillness. Forests disappeared. Oceans emptied of many familiar forms of life. The world became simpler, quieter, and harsher. But catastrophe does not only destroy, it clears space. Small mammals, birds, and resilient plants survived where larger, specialized creatures could not. Slowly, ecosystems reorganized. The world did not return to what it had been. It became something new. These events reveal a central truth about Earth's history. Stability is temporary. The planet is shaped not only by slow, predictable processes, but by rare, overwhelming moments that reset the balance of life. Supervolcanoes and asteroid impacts remind us that Earth does not protect what exists. It tests it again and again. And each time, life responds, reduced, reshaped, but persistent. As time moved forward, catastrophes became more selective. They no longer reshaped the surface alone. They targeted life itself on a massive scale. Whole branches of the evolutionary tree would vanish, leaving only fossils and silence behind. These moments are known as mass extinctions, and they form the next chapter in Earth's long and unfinished story. For now, rest in the quiet aftermath of fire, ash, and darkness, knowing that even here, renewal had already begun. The Great Dying, when life nearly disappeared. For most of Earth's history, life did not grow in a straight line. It expanded, diversified, and filled every available space. And then, without warning, it collapsed. This chapter is about those moments, not moments of localized disaster, not single eruptions or impacts, but global biological catastrophes so severe that life itself nearly vanished from the planet. These events are known as mass extinctions, and they are among the most profound catastrophes Earth has ever experienced. A mass extinction is not simply the loss of many species. It is a fundamental reset. Entire ecosystems disappear. Food webs unravel. Evolution itself is forced to start again from what little remains. To understand these events, it helps to remember something essential about life on Earth. Life is resilient, but it is also finely balanced. Small changes in temperature, chemistry, or atmosphere can ripple outward, quietly destabilizing systems that took millions of years to form. And when those systems collapse, they do not do so gently. The Earth has experienced 5 major mass extinctions. Each one reshaped the planet in a different way. Each one erased worlds that can never be recovered. And each one began not with instant destruction, but with gradual imbalance that reached a breaking point. The earliest of these extinctions occurred long before dinosaurs, forests, or even land animals existed. At this time, life lived almost entirely in the oceans. The seas were warm, shallow, and rich with simple organisms, trilobites, early corals, and countless forms that no longer exist. Then the climate began to change. The planet cooled, sea levels dropped, shallow oceans drained away. Habitats vanished quietly as water retreated from the continents. For marine life dependent on stable, warm seas, this was catastrophic. Species disappeared not in dramatic explosions, but through slow starvation, isolation, and collapse. When the seas returned, much of that life was already gone. But the greatest extinction Earth has ever known was far more severe. It occurred approximately 252 million years ago, at the boundary between 2 geological ages. Today it is known as the Great Dying, and it nearly ended life on Earth altogether. At this time, the continents were joined together in a single massive landmass. Volcanic activity intensified on an unimaginable scale. In what is now Siberia, enormous fissures opened in the crust, releasing lava continuously for tens of thousands of years. These eruptions did not merely cover the land, they changed the atmosphere. Vast quantities of carbon dioxide and toxic gases were released, warming the planet rapidly and acidifying the oceans. Temperatures rose, oxygen levels fell. The seas, once rich with life, became hostile. Marine organisms began to suffocate as oxygen disappeared from the water. Coral reefs collapsed. Shell-forming creatures dissolved as acidity increased. On land, extreme heat made survival difficult for even the hardiest species. Forests died, soil degraded, food chains collapsed from the bottom upward. By the time the catastrophe had run its course, more than 90% of all species on Earth were gone. Life did not simply suffer, it nearly failed. For a long time afterward, the Earth was quiet. The world that followed the Great Dying was sparse and simplified. Ecosystems were reduced to a few resilient survivors, organisms capable of enduring heat, low oxygen, and unstable environments. Recovery took millions of years. Life did return, but it did not resemble what had come before. Evolution had been forced onto a new path. Other mass extinctions followed. Some were driven by climate change, others by rising seas or falling oxygen levels. Each time, life adapted, but always at great cost. Then came the extinction most familiar to us, the one that ended the age of dinosaurs. When the asteroid struck the Earth 66 million years ago, it did not instantly kill everything. Many creatures survived the initial impact, but survival depended not on strength or size, but on flexibility. As darkness covered the planet and temperatures dropped, plants struggled to grow. Large animals dependent on abundant food could not adapt quickly enough. Small mammals, birds, and scavengers endured. In the quiet world that followed, they flourished. The catastrophe did not end life's story. It changed its direction. What these extinctions teach us is subtle but profound. Life on Earth is not guaranteed. It persists not because conditions are stable, but because adaptation never stops. Mass extinctions are not anomalies. They are part of the planet's long rhythm: creation, expansion, collapse, renewal, again and again. As the Earth moved closer to the present, mass extinctions became less frequent, but their lessons remained written into the fossil record. They remind us that the world we know is temporary, that the familiar forms of life around us exist not because catastrophe ended, but because they emerged after it. In the next chapter, we will turn our attention away from deep time and toward humanity. We will explore catastrophes witnessed, recorded, and remembered, floods, collapses, and disasters that shaped ancient civilizations and entered human memory as myth and history. For now, rest with the understanding that even when life nearly disappeared, the Earth continued, quietly preparing for what would come next. When catastrophe entered human memory. For most of Earth's history, catastrophe unfolded without witnesses. There were no voices to remember it, no stories to carry it forward, no names to give to the forces that reshaped the world. But eventually, a species emerged that could observe, remember, and record. And when catastrophe struck again, it entered memory. This chapter is about the moment when Earth's disasters stopped being only geological events and became human experiences. Events felt in fragile bodies, remembered in stories, and passed down as warnings, myths, and history. By the time humans appeared, the Earth had already settled into a delicate balance. Ice ages came and went, seas rose and fell, volcanoes still erupted, but less often on a global scale. For early humans, the planet seemed vast, powerful, and alive. And when it changed, it did so in ways that felt intentional. One of the most significant catastrophes experienced by early humans was not sudden destruction, but gradual transformation. At the end of the last ice age, the world began to warm. Glaciers that had dominated entire continents slowly melted, releasing unimaginable volumes of water into the oceans. Sea levels rose, not gently, but relentlessly. Coastlines shifted. Low-lying lands vanished beneath the waves. Human communities that had lived for generations near rivers and shores were forced to move, often leaving behind places that had once been central to their lives. These were not isolated events. They happened again and again across the world, and they left deep impressions on human memory. Many ancient flood stories may trace their origins to this time. In Mesopotamia, stories spoke of great deluges sent to cleanse the world. In South Asia, tales described cosmic floods that ended entire ages. Indigenous cultures across continents remembered waters that rose suddenly and reshaped the land. These stories were not scientific explanations. They were memory. They preserved the emotional truth of catastrophe, displacement, loss, and survival, long after the waters receded. As humans began to form permanent settlements, catastrophe became more personal. Cities rose near rivers for water and fertile soil, but those same rivers flooded without warning. Earthquakes shattered stone buildings, volcanoes buried towns beneath ash. One of the most famous of these events occurred in the year 79. The city of Pompeii lay near a mountain that had slept for centuries. When it awoke, it did so violently. Ash filled the sky. Streets vanished. Life froze in moments of ordinary routine. Pompeii was not destroyed instantly. Many had time to flee, but for those who remained, the catastrophe was absolute. The city was erased, and in its burial, preserved. These disasters taught early civilizations difficult lessons. They learned that prosperity invited risk, that stability could vanish overnight, that the land which sustained them could also betray them. In response, humans sought meaning. They imagined gods of fire, water, and earth. They built temples to appease forces they could not control. They created rituals, calendars, and warnings. Catastrophe became woven into belief. Sometimes disaster did more than destroy cities. It ended entire civilizations. Around 3,000 years ago, complex societies across the eastern Mediterranean collapsed almost simultaneously. Trade networks failed. Cities were abandoned. Writing systems disappeared. The causes were not singular. Drought, earthquakes, invasions, economic fragility. Together, they formed a cascading catastrophe. The Bronze Age ended not with one event, but with many smaller failures reinforcing one another. It was a reminder that catastrophe can be slow, systemic, and deeply human. Unlike ancient extinctions, human catastrophes did not erase life from the planet, but they reshaped culture. They determined which stories survived, which technologies were forgotten, and which paths civilization would follow next. Every society carried forward the memory of what it had lost, and those memories influenced how humans viewed the world, as unpredictable, as powerful, as something to be respected. By the end of this chapter, Earth had not changed dramatically in form, but humanity had. Catastrophe was no longer distant. It was personal. It lived in stories told at night, in ruins left behind, and in the shared understanding that survival was never guaranteed. In the final chapter, we will step back and look at the entire pattern. We will explore what all these catastrophes, cosmic, geological, biological, and human, reveal about the Earth itself, not as a place of endless destruction, but as a system shaped by change. For now, rest with the understanding that when catastrophe entered human memory, it also gave rise to meaning. As our journey comes to its end, it becomes clear that the Earth's greatest catastrophes were never isolated events. They were chapters in a single continuous story. A story written not in years or centuries, but across billions of years of change, collapse, and renewal. From the very beginning, the Earth was shaped by forces far beyond control or intention. Asteroids collided, continents burned, oceans froze and thawed. And yet, through every catastrophe, the planet endured. What we have seen across these chapters is not a world bent on destruction, but a world in motion. The early Earth survived chaos by transforming it into structure. Fire became land, steam became ocean. Later, life survived catastrophe by adapting, not by resisting change, but by moving with it. Each extinction cleared space. Each collapse opened possibility. Nothing was permanent, but nothing was meaningless. Even the most devastating events, the supervolcanoes, the asteroid impacts, the mass extinctions, did not end the story. They redirected it. They altered the course of evolution, reshaped ecosystems, and quietly prepared the conditions for what would come next. In this way, catastrophe was not the opposite of creation. It was part of it. When humans arrived, the pattern continued. Floods erased settlements, earthquakes shattered cities. Civilizations rose, flourished, and collapsed. And still, humanity endured, learning, remembering, and passing forward the lessons of loss. Through myth, science, and history, humans tried to understand what the Earth had always been doing, changing. Perhaps the most comforting realization is this: the Earth does not move toward perfection, it moves toward balance. That balance is never fixed. It shifts slowly, sometimes violently, but always forward. Catastrophe is not a sign that something has gone wrong. It is a sign that something is changing. As you rest with this story, it may help to remember that the ground beneath you has survived far worse than anything you will ever know. It has endured fire hot enough to melt continents, ice thick enough to cover oceans, and darkness long enough to erase entire worlds. And still, it carries you, quietly, patiently. The complete history of the Earth's greatest catastrophes is not a warning meant to frighten. It is a reminder that change is constant, that survival is possible, and that even after the greatest endings, something new has always begun. Thank you for taking this long journey through deep time. May the story linger gently as you rest, and may the quiet resilience of the Earth bring you calm. When the oceans turned against life. For much of Earth's history, the oceans were not only a home for life, they were life. Long before forests covered the land or animals walked beneath the sky, the seas held nearly every living thing the planet possessed. They appeared vast, stable, and eternal. But the oceans, like the Earth itself, were never truly calm. They could change slowly, quietly, and completely. And when they did, the consequences reached across the entire planet. This chapter is about the moments when the oceans turned against life, not through sudden violence, but through invisible shifts that unfolded beneath the surface, unnoticed until it was almost too late. The oceans are deeply sensitive systems. They respond to temperature, chemistry, and circulation in ways that are not immediately visible from above. A small rise in heat can reduce oxygen. A slight change in chemistry can dissolve shells. A disruption in currents can starve entire ecosystems. When these changes happen gradually, life adapts. But when they happen too quickly, the oceans become hostile. One of the most devastating oceanic catastrophes in Earth's history involved a process known as anoxia. Anoxic events occur when oxygen levels in the water drop so low that most marine life can no longer survive. At first, these conditions appear only in deep waters, where circulation is limited and organic matter decays slowly. But under certain conditions, anoxia spreads upward. Warm temperatures prevent oxygen from mixing downward. Nutrients fuel massive blooms of microscopic life. As those organisms die, they consume what little oxygen remains. The water becomes silent. During these periods, entire regions of the ocean turn dark and lifeless. Fish suffocated. Bottom-dwelling creatures vanished. Reefs collapsed as their foundations dissolved. In some cases, toxic bacteria flourished, releasing gases that further poisoned the water. What made these catastrophes especially powerful was their reach. Unlike earthquakes or eruptions, oceanic collapse did not remain localized. Currents carried oxygen-poor water across vast distances. The disaster moved slowly but it moved everywhere. Several of Earth's mass extinctions were closely tied to these oceanic failures. Life did not always die because of impact or fire. Sometimes it died because the seas could no longer breathe. Shell-forming organisms were especially vulnerable. As carbon dioxide levels rose in the atmosphere, the oceans absorbed it, becoming more acidic. Shells weakened, structures dissolved. Species that had survived for millions of years quietly disappeared. The ocean, once a cradle of life, became an agent of loss. These changes were not immediately visible from land. There were no towering waves or collapsing coastlines. The surface often appeared calm, but beneath that calm, entire ecosystems unraveled. This is what made oceanic catastrophes so profound. They were silent. And by the time their effects reached the shore, recovery was already distant. Yet even here, the familiar pattern emerged. After oxygen returned, life reappeared. Different species, different balances, different relationships. The oceans did not restore what was lost. They reinvented themselves. New forms of plankton reshaped food webs. New predators emerged. Reefs rebuilt slowly in altered forms. The sea remembered catastrophe, but it also moved beyond it. These ancient oceanic disasters continue to echo today. Layers of dark sediment, rich in organic material, still mark the moments when oxygen vanished. They are quiet records of failure and survival, written into the seafloor itself. They remind us that the greatest catastrophes are not always sudden. Sometimes they arrive gradually, changing conditions so subtly that life does not realize what is happening until adaptation is no longer possible. As we move forward in this story, the focus will shift again, from the depths of the oceans to the delicate balance of climate and atmosphere. We will explore catastrophes that unfolded without explosions or impacts, driven instead by invisible shifts in temperature, rainfall, and time. For now, rest with the image of the ancient seas, vast, powerful, and vulnerable. And remember that even the deepest systems on Earth are shaped by change. The silent killers. Climate shifts without impact. Not every catastrophe in Earth's history arrived with fire, noise, or sudden destruction. Some of the most powerful changes unfolded quietly, without explosions, without collapsing ground, and without a single dramatic moment that could be clearly remembered. These were catastrophes driven by climate itself. Slow shifts in temperature, rainfall, and wind patterns that altered the world so gradually that life often failed to recognize the danger until adaptation was no longer possible. This chapter is about those silent killers. Climate is not a fixed condition, it is a moving system shaped by the balance between sunlight, atmosphere, oceans, and land. When that balance shifts, even slightly, the consequences can ripple outward for thousands of years. A small cooling can expand ice. A slight warming can dry entire regions. A subtle change in rainfall can determine whether civilizations flourish or fade. And because these changes happen slowly, they can be far more dangerous than sudden disaster. Throughout Earth's history, climate has changed abruptly, sometimes within a few decades. Ice core records reveal sudden drops in temperature, periods when the planet cooled or warmed far faster than ecosystems could adapt. Forests retreated, grasslands expanded. Animals followed food sources into unfamiliar territory. Those that could not move, change diet, or adapt physiology simply disappeared. No impact announced their end. No eruption marked the moment. The world simply became different. One of the most powerful examples of silent catastrophe is prolonged drought. Rainfall patterns are deeply connected to ocean currents and atmospheric circulation. When those systems shift, regions that once received steady rain can become dry almost overnight in geological terms. Rivers shrink, soil hardens, vegetation thins. What begins as reduced rainfall becomes famine, migration, and collapse. This pattern has repeated itself many times across Earth's history. For early human societies, these climate shifts were devastating. Entire civilizations depended on predictable seasons. When rains failed year after year, crops died, food stores vanished, and social order weakened. Cities were abandoned not because of invasion, but because the land could no longer sustain life. The catastrophe left no ruins of fire or destruction, only empty spaces where people once lived. Climate shifts also reshaped the natural world long before humans arrived. During periods of rapid warming, ice melted and seas rose, flooding low-lying regions and erasing habitats. During cooling periods, glaciers advanced, grinding landscapes into silence. Species that thrived under one climate found themselves unprepared for another. Extinction did not arrive suddenly. It arrived quietly through mismatch. What makes these catastrophes especially difficult to understand is their invisibility. There is no single day when climate collapse begins. There is no clear boundary between stability and crisis. Change accumulates slowly until a threshold is crossed, and once crossed, recovery can take thousands of years. Yet even these silent disasters followed Earth's familiar rhythm. After drought came rain. After cold came warmth. After instability came new balance. Life adapted again, not by returning to what had been lost, but by creating something new. Grasslands replaced forests. Cold-adapted species emerged. New ecosystems formed where old ones had vanished. These climate-driven catastrophes remind us of a quiet truth. The Earth does not require violence to change. It only requires imbalance. And imbalance, once established, can reshape the world more thoroughly than any single event. As we move forward, the lens will widen even further. We will explore moments when catastrophe almost occurred, when the Earth came close to profound change, but instead passed through narrow margins of survival. For now, rest with the understanding that the most powerful disasters are not always loud. Sometimes they arrive as silence, stretching across generations, reshaping the world while no one is watching. Earth's forgotten, near misses. Not every catastrophe in Earth's history fully arrived. Some came close enough to leave marks in stone and memory, yet stopped just short of transforming the planet entirely. These are the near misses, moments when the Earth passed through narrow corridors of chance, avoiding outcomes that might have reshaped life beyond recognition. This chapter explores those quiet, often forgotten moments when catastrophe hovered at the edge of possibility, and survival depended on timing, distance, and delicate balance. Throughout deep time, the Earth has shared its space with countless wandering bodies. Asteroids, comets, and fragments of long-destroyed worlds move silently through the solar system, following paths that can remain stable for millions of years or shift suddenly due to the gravity of larger planets. Many of these objects passed close to Earth, close enough to alter tides, disturb orbits, or ignite the sky with light. Yet they missed, by margins that, in cosmic terms, were impossibly small. Geological records show signs of impacts that were large, but not large enough to trigger global extinction. Craters scattered across continents tell stories of collisions that could have been far worse. Had these objects arrived slightly earlier, slightly later, or at a different angle, the outcome might have been catastrophic on a planetary scale. Instead, the Earth absorbed the blow and continued. There were also moments when Earth's internal systems approached dangerous thresholds. Supervolcanoes accumulated enormous pressure beneath the surface, yet failed to erupt. Magma chambers cooled just enough. Crust fractured harmlessly. The catastrophe that seemed inevitable simply did not occur. In these moments, silence replaced disaster. Ice ages, too, experienced near misses. At several points, the planet cooled dramatically, approaching conditions that might have locked Earth into a permanent frozen state. But subtle changes in solar radiation, atmospheric gases, or volcanic activity reversed the trend. Ice retreated. The world warmed. Life endured. Perhaps one of the most significant near misses involved Earth's magnetic field. The magnetic field shields the planet from harmful solar radiation, deflecting charged particles that could otherwise strip away the atmosphere. Throughout Earth's history, this field has weakened, shifted, and even reversed. During these periods, the planet became more vulnerable, but the field never vanished completely. Had it done so, Earth's surface might have become hostile to life as we know it. Instead, the magnetic shield returned, quietly. These near misses reveal an important truth. Survival is not always the result of strength or resilience. Sometimes it is the result of chance. A slight change in trajectory, a delayed eruption, a temporary stabilization. Tiny differences, multiplied across vast systems, determine outcomes that shape billions of years. What makes these moments especially fascinating is that they leave few obvious signs. Unlike major catastrophes, near misses do not always leave mass graves or extinction layers. Their evidence is subtle, a thin layer of sediment, a chemical anomaly, a crater that did not change the world. And yet, their importance is immense. If catastrophe defines what Earth has endured, near misses define what it has avoided. Together, they frame the narrow path along which life has traveled. A path shaped not only by destruction, but by moments when destruction almost occurred, and then didn't. As we continue, the perspective will widen even further. We will step back from individual events and explore the deeper forces that made survival possible at all. Chance played a role, but chance alone is not enough. In the next chapter, we will explore why Earth endured when other worlds did not, and what delicate balances allowed life to persist here, while nearby planets became barren. For now, rest with the quiet realization that sometimes the most important events in history are the ones that never happened. Why Earth endured. When other worlds did not. When we look beyond Earth, we see a solar system filled with reminders of what might have been. Worlds that formed from the same ancient cloud of dust and gas now exist in vastly different states. Some are frozen and silent, some are scorched and hostile. And only one, as far as we know, carries life. This chapter explores why Earth endured, not as a result of destiny or perfection, but through a rare and delicate balance of forces that allowed catastrophe and survival to coexist. Earth's position in the solar system played a crucial role. It formed at just the right distance from the Sun, where temperatures allowed water to exist as liquid rather than vapor or ice. This region, often called the habitable zone, is not a guarantee of life, but it provides opportunity. Too close, and oceans boil away. Too far, and they never form. Earth remained balanced between these extremes, even as the Sun slowly brightened over billions of years. The planet's size also mattered, large enough to hold an atmosphere, yet small enough to avoid crushing pressures. Earth's gravity retained water and gases, while allowing heat to escape slowly rather than catastrophically. This balance prevented both runaway heating and rapid freezing. It allowed Earth to change gradually rather than collapse. One of the most important factors in Earth's endurance was its magnetic field. Generated by the motion of molten metal deep within the core, this invisible shield deflected harmful solar radiation and protected the atmosphere from being stripped away. Mars, once wetter and warmer, lost much of its magnetic field early. Over time, its atmosphere thinned, water disappeared. The planet became cold and dry. Earth avoided this fate, not because it was stronger, but because its internal engine continued to run. The presence of the Moon also shaped Earth's survival. By stabilizing the planet's tilt, the Moon prevented extreme climatic swings that might have made long-term life difficult. Seasons remained predictable enough for ecosystems to adapt and persist. Tides mixed the oceans, supporting circulation that distributed heat and nutrients. What began as a violent collision became a lasting influence on stability. Earth's geology played a role as well. The movement of tectonic plates recycled carbon between the atmosphere, oceans, and interior. This slow process regulated climate over immense spans of time. When carbon levels rose, weathering increased. When temperatures fell, volcanic activity returned gases to the atmosphere. This feedback loop acted like a planetary breathing system, preventing permanent extremes. Catastrophes still occurred. Impacts struck. Volcanoes erupted. Extinctions reshaped life. But Earth's systems absorbed these shocks without collapsing entirely. Change was severe, but recovery remained possible. Perhaps the most important factor was not any single condition, but the interaction between many. Position, size, magnetic field, Moon, and geology worked together, creating resilience through complexity. Earth endured not because catastrophe was absent, but because it never overwhelmed every system at once. As we step back from comparison and move forward in this story, the focus will shift once again. From survival itself to the role catastrophe played in shaping creativity, diversity, and innovation. In the next chapter, we will explore how destruction became a creative force, not by intention, but through opportunity. For now, rest with the understanding that Earth's endurance was never guaranteed. It was earned again and again through balance, chance, and change, when destruction became a creative force. At first glance, catastrophe appears to be the enemy of life. It destroys environments, removes stability, and erases what once existed. But when we step back and look across deep time, a quieter pattern begins to emerge, one that reveals destruction not only as an ending, but as a powerful and unexpected source of creation. This chapter explores how catastrophe, again and again, became the force that opened space for something new to appear. Life, once established, tends toward stability. Species adapt to their surroundings, specialize, and fill available niches. Over long periods of calm, ecosystems become efficient, but also rigid. When conditions remain unchanged for millions of years, dominant forms of life expand until little room remains for experimentation. In these moments, innovation slows. Then, catastrophe arrives. When a disaster disrupts an ecosystem, it removes the familiar structures that once controlled survival. Dominant species vanish, Food chains collapse, habitats empty. At first, this appears purely destructive, but beneath the loss, opportunity quietly forms. With competition reduced, survivors gain access to new resources. Traits once considered unimportant suddenly become advantages. Adaptability replaces strength. Flexibility replaces size. After mass extinctions, evolution often accelerates. This is not because catastrophe improves life, but because it clears space. When ecosystems reset, life is forced to explore new forms, new strategies, and new relationships. Small mammals, once confined to the margins, expanded after the dinosaurs vanished. Plants diversified rapidly after climate shifts altered landscapes. Each catastrophe narrowed the present, but widened the future. This creative force was unintentional. The Earth does not seek improvement, it simply changes conditions. Life responds, sometimes poorly, sometimes brilliantly. What survives does not do so because it is superior in all ways, but because it fits the new reality. Even geological destruction contributed to creativity. Volcanic eruptions formed new land, creating islands that became laboratories of evolution. Mountain ranges altered climate and rainfall, dividing populations and encouraging divergence. Glacial cycles fragmented habitats, forcing species into isolation where new traits could emerge. Catastrophe rearranged the map, life filled the gaps. Human history reflects this pattern as well. Civilizations rebuilt after collapse with new technologies, beliefs, and social structures. Old systems gave way to innovation under pressure. While suffering was real and devastating, change followed. Creativity did not erase loss, it emerged from it. This does not mean catastrophe should be welcomed, only that it cannot be understood solely as destruction. In Earth's long story, catastrophe has repeatedly acted as a gate, closing one path while opening countless others. The world we know today exists not despite catastrophe, but because of it. As we approach the final chapters of this journey, the focus shifts once more. From creation itself to memory. The Earth remembers catastrophe, not through stories or emotion, but through layers, scars, and silent records preserved in stone. In the next chapter, we will explore how the planet keeps these memories and how scientists learn to read them. For now, rest with the understanding that even the most destructive forces have shaped the richness of life that followed. What the Earth remembers. The Earth does not remember catastrophe the way humans do. It does not recall events as stories or preserve them through emotion or language. Instead, the planet remembers through layers, through stone laid down slowly, through scars pressed into the surface, and through chemical traces left behind when the world changed. This chapter is about those memories and how the Earth quietly carries the record of everything it has endured. Every catastrophe leaves a mark. Some are obvious, like impact craters that remain visible for millions of years, their circular outlines slowly softened by erosion and time. Others are far more subtle. A thin layer of ash spread across continents, a sudden change in the chemistry of ocean sediments, a sharp boundary in rock where familiar fossils abruptly disappear. These are not accidents, they are memories. In many places, the Earth's history is written vertically. Layer upon layer of sediment builds slowly, each one capturing a moment in time. Most layers represent long periods of relative calm, steady accumulation, slow change, quiet persistence. But catastrophe interrupts this rhythm. A sudden flood deposits coarse debris. A volcanic eruption blankets the land in ash. An impact scatters rare elements across the globe. These layers stand out. They mark moments when the normal rules were briefly suspended. Some of the most powerful memories are hidden beneath the oceans. On the seafloor, fine sediments settle gently year after year, creating an almost uninterrupted record of Earth's climate and chemistry. When oxygen disappears, dark layers form. When temperatures rise, shells dissolve. When life collapses, diversity vanishes from the record. The oceans remember not through shape, but through absence. Fossils are another form of memory. They are not just records of what lived, but of what survived. After mass extinctions, fossil layers often become sparse, containing fewer species and simpler forms. These gaps speak as clearly as abundance. They tell of worlds that ended and of long recoveries that followed. Even the movement of continents carries memory. Mountain ranges preserve the scars of collision. Folded rock reveals the pressure of ancient impacts. Fault lines trace the boundaries of forces that have never truly rested. The surface we walk on today is not young. It is layered with consequence. What makes Earth's memory unique is its patience. Nothing is erased quickly. Even when erosion smooths the surface, the deeper record remains. Catastrophe does not vanish. It sinks into the planet, waiting to be read. Humans learned to interpret these memories only recently. Through careful observation, measurement, and comparison, scientists discovered how to read the language of stone. They learned to recognize extinction boundaries, identify past climates, and reconstruct worlds that no longer exist. In doing so, humanity gained a longer view of time, one that places our own experiences within a much larger story. These memories serve a quiet purpose. They remind us that stability is temporary, that change is constant, and that the Earth has endured far more than we can imagine. They do not predict the future, but they provide context. As we approach the final chapter, the focus turns toward the spaces between catastrophes, the long stretches of calm that followed upheaval, and the silence in which life quietly rebuilt. Because catastrophe shapes the story, but calm allows it to continue. For now, rest with the image of the Earth as a patient keeper of memory, holding every chapter, every ending, and every beginning beneath its surface. The long calm between disasters. When we look back across the Earth's history, it is easy to focus on catastrophe, asteroid impacts, supervolcanoes, extinctions, floods, and collapses. These moments stand out because they are dramatic, because they divide time into before and after, because they leave unmistakable marks in stone and memory. But they are not the whole story. Between every catastrophe lies something far greater in duration. Silence. For millions of years at a time, the Earth has known long periods of relative calm. Not perfection, not stillness, but balance. During these stretches, continents drift slowly, climates fluctuate gently, and life expands into every available space. Forests grow and retreat. Oceans circulate nutrients. Species evolve without pressure to radically change. This calm is not empty. It is productive. Most life on Earth has lived and died during these quiet intervals. Most species never experienced global catastrophe at all. They adapted to local conditions, competed, survived, and disappeared naturally as environments shifted slowly around them. From a deep time perspective, catastrophe is rare. Calm is the rule. These long intervals allowed complexity to develop. Ecosystems layered themselves with relationships built over thousands of generations. Balance emerged not because the Earth was gentle, but because change slowed enough for life to settle. Predators and prey co-evolved. Plants shaped atmospheres. Microorganisms altered oceans. Life did not rush. It accumulated. Even after the greatest disasters, it was calm that allowed recovery. After mass extinctions, the planet did not immediately surge with new life. It rested. For millions of years, diversity remained low while systems stabilized. Only then did expansion begin again. Calm was not the absence of catastrophe. It was the space in which healing occurred. For humans, calm is often overlooked. History emphasizes collapse, war, and disaster, while long periods of stability fade into the background. But civilization itself depends on extended calm. Agriculture requires predictable seasons. Culture requires continuity. Memory requires time. Without calm, nothing lasts. When we place humanity within Earth's full story, a quiet perspective emerges. We are living in one of those long intervals, not free from risk, not immune to change, but supported by balances built over immense time. The ground beneath us has rested before, and it will rest again. The complete history of Earth's greatest catastrophes is not a tale of doom. It is a lesson in scale. Catastrophe reshapes, calm sustains. Both are necessary. Both are temporary. Together, they form the rhythm of a living planet. As this story comes to a close, you may notice that the Earth no longer feels like a place defined by destruction. Instead, it feels ancient, patient, and enduring. A world that has fallen apart many times and quietly rebuilt itself each time without memory, anger, or fear. If you are listening late at night in a quiet room, while the world feels still, remember that this stillness has existed before, for millions of years at a time. And it will exist again. The Earth knows how to continue,